Hey guys, in this video we're going to learn how to create a space shooter game using Python. In particular, we're going to cover chapter 12 of the book Python Crash Course. We already learned the basics of Python in the previous episodes of this series. Now we're going to apply that knowledge in a number of different projects. First we're going to create a game using Python, then we're going to work on a project in data visualization, and finally we're going to learn about web application development using Django. In today's video we're going to learn about Pygame and how to create a game using Python. In particular, we're going to create a space shooter and learn how to set up a game, how to navigate, and how to shoot bullets using Pygame. Let's get right into it. Now the first project we're going to focus on is a game that we're going to develop. Specifically, we are going to develop a Space Invader game called Alien Invasion. In order to do that, we are going to use Pygame, which is a collection of Python modules that we can use to write a game. It supports us with graphics, animation, and also sound. And while we build this game, we'll also learn how we can manage large projects that span multiple files, because we are going to have multiple files creating this game. We'll also refactor a lot of code and manage file contents to organize a project and make the code more efficient. So in order to get started, the first thing we need to do is to ensure that we create a new folder. So ideally we create a separate projects folder, and inside of that we can create a new Alien Invasion folder. And inside of that folder we are then going to install Pygame and start creating our game. Now before we get started, we of course need to plan our project, and it typically makes sense to kind of prepare a plan before we start writing code. So for Alien Invasion, the player will control a rocket ship that appears at the bottom center of the screen, and then the player can move the ship to the right or left using the arrow keys and shoot bullets using the spacebar. And when the game starts, a fleet of aliens will fill the sky coming from the top, and it's our job to shoot down those aliens before they either hit the player or reach the bottom of the screen. Now in order to get started, let's install Pygame. For this we can head over to our terminal, and as you can see I already created a folder called alien_invasion. So it makes sense to create such a folder, and then we are going to create all subsequent files for our game inside of this folder. In order to install Pygame, we need to enter this command. So we're going to use pip to install Pygame on our system, and as we run this, it's going to download all required files. Now in my case I already installed it ahead of time, but if you run it, then Pygame will be installed on your system. Now we begin building the game by creating an empty Pygame window, and then later on we're going to use it to draw the game elements inside of that window, such as for example the ship that we control and also the aliens that we want to shoot down. We'll then also make the game respond to user input, set the background color, and load a ship image. So in order to create an empty Pygame window, we need to create a class to represent the game. So in our text editor we can create a new file that we can call alien_invasion.py. So here we initially import the Pygame module that we just installed, and also the system module, which we need to, for example, close the window, and then we define our class here. So we create a class for the game Alien Invasion, which is the overall class to manage the game methods and behavior. Of course we have an init method inside of our Alien Invasion class, which is going to initialize our game by calling init on Pygame. And then we also set the size of the screen in pixels, so here 1200 times 800. And we also add a caption here, Alien Invasion. We have a second method inside of this called runGame. So this is going to start the main game loop for the game. So here we are looking for input from a user, and then we are going to react based on that. And initially all we do is we check if there is a pygame.quit event, which happens when we click on the X icon to close the window. And then we are referencing sys, so therefore that's the reason why we needed to import the system module here, and we call exit on it. So this will help us actually close the window. And then we also want to make sure that the most recently drawn screen will be visible, so therefore we call on Pygame, on the module we imported, we call display and then flip. This will become more relevant later on as we add, for example, the ship as an element to our screen. And then here at the very bottom, we want to make sure that we create a game instance and run the game when we execute this file here. So that means we instantiate Alien Invasion, the class we defined up here. And then on that object we created, we are going to call run game, so this method here, and that's going to start our game. And especially later on, as we add additional elements, for example our spaceship or aliens later on, it's important to note that this line here, Pygame display flip, this ensures that the new elements are showing up on the display, and also that it shows the new position of game elements and hides the old ones, so that we have the illusion of actual movement going on. So let's take a look at what this actually looks like. So if we now go ahead and we execute our file, we can see we have such an empty screen showing up. We have the caption here that we specified. That's not very interesting at the moment, but Pygame allows us to basically create this window here, and then later on, of course, to basically run our game inside of that. And by clicking on the X icon on the top left side, this is basically what happens here inside of our run game method. So here we have an event listener, meaning we are listening for any user input. And if we get an input of type pygame.quit, which is basically transmitted when we click on the X icon, if that's the case, then we basically close down this window. If we didn't have this line here, nothing would happen when we click on the X icon. So as we just saw, Pygame creates a black screen by default when we run that program, but that's quite boring. So one of the first changes we can make is to actually change the background color. So let's do that. It's actually pretty straightforward. All we need to do is to basically set the background color attribute here to a specific color. And in this case here we are entering RGB colors. So RGB colors can range from a value of 0 to 255. And so for example, the first component here is referring to the red component of the color. So if we set that to 255, this would be the maximum value for the color red. And then of course, if we want to have pure red, we would set this to 255, and then the other two values would be set to 0, and then we would get pure red. The second component here is then the amount of green that we want to use, and the last one is the amount of blue. And by doing that, we can basically control and set each color that we want to use, so we get a total of up to 16 million possible colors that we set. So here we are setting values for all three components, for red, green and blue, and we are all setting them to 230, so we basically mix equal amounts of red, blue and green, and thereby we get a light gray background color. So that's what we specify here inside of our init method. And then of course we also need to make sure that we actually update this and display that on the screen. And for this we have this section here. So we redraw the screen inside of our while loop, and here we then update the screen fill color to use the background color that we defined up here. And we need to note that we need to use self, of course, because this attribute here, this variable, was defined outside of the current method inside of the init method. So with those two lines added, let's actually head back and let's run our program again. And let's take a look at what this looks like now. And now we can see instead of this black background that we had before, we now have a gray background. Now, each time we introduce some new functionality into the game, we typically are going to create some new settings as well. And instead of just adding all those settings inside of our code here, it makes sense to create a separate module, settings, that contains a class called settings to store all these values in one place. So if we need to make some changes, we can just change that in our settings module. And especially if we have a number of different files that use the same settings class, that is a single place where we can actually make those changes, and it will take effect basically everywhere. So in order to do that, we need to create a new file named settings.py in the same folder. If we take a look at that, all we do here is basically inside of our settings module, inside of our settings.py file, we have a settings class and we have an init method. And inside of this init method here, we store the different game settings. So we moved the screen width and the screen height, which in the previous version we just hard-coded in here. We now moved that to the settings class. And that allows us to easily adjust those values. So if we maybe later on want to release our game for a different screen size, maybe for a smartphone, then we could simply adjust that here. And we also moved the background color in here, so if you want to adjust that later, we have one single file where we can add that into. Now that of course means that we need to import the settings into our Alien Invasion file. So if we take a look at this Alien Invasion file here, we can see that from the settings module, we import the settings class. And then of course, we also need to make sure that we instantiate that class here. So here we call we define self.settings, and we call our settings class, which of course we imported in this line up here. And now wherever we originally hard-coded the values, we are now going to reference the values associated now with this self.settings object. So that means when we display our resolution here, instead of hard-coding the values of 1200 and 800, we instead reference self.settings, which of course is the object up here, and then we call screen width on it. If you take a look at the settings file, that's exactly the first value here, the first attribute here, with a value of 1200. And then we do the same with screen.height, which of course is the 800 pixels of height that we have. And we also need to update this line here, of course. We are not hard-coding the color in here, but instead we call self.settings and then reference the background color again, which we specified inside of the settings file. And if later on we have maybe not just the Alien Invasion file here, but maybe another game file, then we can again just import the values from our settings module. And if we need to make some changes, we just need to change it in a single file here, and it will apply everywhere. So that's a very handy approach that we can take. Now let's add the actual ship to our game, so the player that we are going to control. And in order to do that, we need to load an image and then use a Pygame method called blit to draw the image actually. And when we are choosing artwork for our games, we need to make sure that we pay attention to licensing, of course. So one of the safest and cheapest ways is to use a freely licensed graphic. There are, for example, some available on pixabay.com. Can use almost any type of image in our game, but it's typically easiest when we use a bitmap file, because Pygame loads bitmaps by default. So in order to do that, we can basically select any file that should not be licensed, for example a JPEG or PNG file, and then we can convert that to a bitmap file. And ideally we should get a file that has either no background color or a transparent background color, so we can replace that later on. So our game will look best if the image background color matches our game's background color. So for Alien Invasion, we can use a specific file that can be downloaded from the book's website. And if we take a look at this, we can create an images folder. And inside of that, we have, for example, here our ship.bmp file, which is a file that we are going to work with. So next we'll create a new ship module that will contain the class ship, and then this class will manage most of the behavior of the player's ship. So let's take a look at that. Here we have the ship.py file. Again, that's in the same folder as our Alien Invasion file. And here, of course, again, we need to import Pygame in order to access the different methods associated with that module. And then we specify our ship class. So this ship class has an init method here, used to initialize the ship and also to set the starting position. And then it also has a blitme method here, which is used to draw the ship at its current location. Pygame is quite efficient because it lets us treat all game elements like rectangles. So even if they don't exactly are shaped like rectangles. And that can be really efficient because then we need to do fewer computations and our game can run much more smoothly. Inside of our ship class, our init method takes an additional attribute aside from self. It also takes the AI game. So we pass the game to it, and that has the benefit that we can access all the different attributes and methods associated with the game itself. So at first we assign the screen to an attribute of ship so we can access it easily in all the methods inside of the class. And then we access the screen's rect attribute using getRect and assign it to self.screenRect. And that allows us to place the ship in the correct location on the screen. So in order to load the image which we are going to use, we are calling image on Pygame, and then we are calling load, and we need to pass in the path where our file actually is. So this is inside of our images folder, and the file is called ship.bmp, and that's assigned to self.image. So when the image is loaded, we call getRect to access the ship's surface rect attribute so we can later use it to place the ship. And whenever we are working with a rect object, we can use the x and y coordinates of the top, bottom, left and right edges of the rectangle, as well as the center to place the object. And important to note, in Pygame the origin 00 is actually on the top left side corner, and that increases as we go down and to the right of our screen. So we are going to position the ship at the bottom center of the screen, and to do that we make the value of self.rect.midBottom match the mid-bottom attribute of the screen rect in this line here. And then finally, of course, we have our splitMe method, which draws the image to the screen at the position defined by self.rect. Now, in order to actually work with the ship, we of course also need to update our Alien Invasion class. So if we take a look at that, we need to initially of course make sure that we actually import that class ship from the module ship, from the file we just wrote. And then additionally to that, we are going to instantiate our ship class of course. And we create a new attribute, self.ship, which we can then use later on. And if we scroll down a little bit, here actually in the area where we redraw the screen, we are then calling splitMe on our self.ship object, and that allows us to basically draw our image to the screen, so we add the spaceship to the screen. Alright, so let's run our code one more time. And now we can see our image, the ship, is actually drawn at the bottom of the screen. So this is how we can display images in our game. Now of course we also need to be able to actually control them and navigate them. But before we do that, let's refactor some of our code. So especially in larger projects, we'll often need to refactor our code we've written before when we add more code. And refactoring helps us simplify the structure of our code that we have already written, making it easier to build on. So we are next going to break the run game method, which is currently quite lengthy, as we can see here. We want to break that down into a number of different helper methods. So a helper method does work inside a class, but isn't meant to be called through an instance. In Python, a single leading underscore indicates a helper method. So first of all, we want to create a check events method. So we are going to move the code that manages events to a separate method, and that's going to simplify our run game method. So let's take a look at that. Here we can see that inside of run game, we now have a helper method, which we can identify by the leading underscore, which is called underscore check events. And if you look down here, we can see our helper method check events, which contains precisely the same code that we had before directly inside of our run game method. And the benefit here is that it isolates the event management loop, and isolating the event loop allows us to manage events separately from other aspects of the game, such as updating the screen. To further simplify run game, we can create a second helper method, update screen. So as we can see here, we are calling that right underneath check events, and we move all the screen updates here, for example displaying the background color and also displaying the ship. We are moving that inside of update screen, the helper method, and call this method up here. So if you've already built a number of games, then we'll probably start to break out code into methods like these. But if you've never tackled a project like this, we probably won't know how to best structure our code, and that's exactly the approach refactoring takes. So here we can restructure our code as it grows more and more complex, and we can simplify it. So typically we want to start out writing our code as simply as possible and then refactor it as our project becomes more complex. So let's take a look at a couple of exercises. We should initially create a Pygame window with a blue background, and then we should also add an additional game character, which should be a bitmap image, and we should draw that character at the center of the screen. So let's take a look at that. First of all, in order to adjust the background color, all we need to do is to head over to our settings class and then to adjust the background color here. So if you want to use a blue color, if we think back, we have the red and the green component and the blue component. So we are only using the blue component here, and we're removing or setting the red and green component to 0. So we're gonna get a blue color here. And in order to apply the setting, we can simply say that instead of importing that from our regular settings file, we're going to adjust that to exercise 1. And now if you run our code again, let's just close this down here for a second. Then we should actually get a blue background. And here we can see indeed we have a blue background here being applied because we adjusted the background color. It doesn't look as nice because now we have this kind of image here which has a different background color, so we should probably adjust it as well. But this is how we can adjust the background color. And then in addition to that, of course, we should also add a new game character. So here, for instance, I downloaded an image of Mario, Super Mario, and again we are defining an init method here, which also takes not just self but also the game class itself as an input. We are going to get the rectangle here, and of course we are also importing the settings. And then we are loading the image. Inside of the images folder I have a mario.bmp file, which we can see if we just head over to our images file. We can see there's a Mario image in here, which is going to be used. And then we should position that at the center of the screen. When we sync back the ship that we positioned, we positioned that at the bottom center. But here we want to position that in the center. So here we're saying self.rect.center, and we set that to self.screenRect.center. And then of course we need to draw that as well. So now we can decide to import that. So we basically say instead of importing the ship class, we can say we want to import from our exercise 2 file here. We want to import the Mario class. Then of course we need to instantiate our class, and again we pass self to it, which again is the game object that we reference inside of our class here. And once instantiated, we then of course need to update this. So in this case I'm going to say self.mario.blitme. Let's remove the comment out the game for now. Now we called blitme on Mario as well, so now it should be positioned, and since we defined blitme to draw it to the screen using the rect coordinate and we set rect to center, it should actually be positioned in the center of the screen. So let's run this program again. Now we can see we have an image of Mario here in the center. We have our blue background, so this is how we can adjust both our background color and add additional images to our screen. Now, next we want to make sure that the player actually can navigate the ship to the right and left. So we're going to write code that responds to when the player presses the right or left arrow key. So we'll focus on movement to the right first, and then we'll apply the same principles to to the movement of the left. So whenever the player presses a key, that key press is registered in Pygame as an event, and each event is picked up by the pygame.event.get method. So we need to specify in our check events helper method what kind of event we want the game to check for, and each key press is registered as a key down event. So let's take a look at that, and all we need to do is basically to say inside of our check events method, inside of our game loop, we initially check if we have a pygame.quit event, meaning we are checking if a user clicked on the X button to close down the window, and then of course we exit the program. Alternatively, we are now adding this section here, so we are checking for a key down event, and if the event key is the right key here, then we are going to change the position of the image, so we are going to increase that by 1 pixel. So let's see if that works properly, and let's run our program again. And we can see again, if we now press the right key, we can move our ship to the right, but that's not a very efficient way to navigate, because we always have to press the right key to move the player to the right 1 pixel. So what we actually want to achieve is to easily navigate if we hold down the right key. When the player holds down the right arrow key, we want the ship to continue moving to the right until the player releases the key. To do that, we'll have the game detect a Pygame key up event, so we'll know when the right arrow key is released. And then we'll use the key down and key up events together with a flag called moving right to implement continuous motion. So since the ship class controls all attributes of the ship, we'll give it an attribute called moving right and an update method to check the status of moving right, and an update method to check the status of the moving right flag. So the update method will change the position of the ship if the flag is set to true. And then we call that method once on each pass through the while loop to update the position of the ship. So inside of our ship class, we are going to add a movement class, initially just for moving right, and we're going to set that to false initially inside of the init method. And then we add an additional update method here, and that is checking if moving right is set to true, and if that's the case, we're going to update this by 1 pixel. And if that's not the case, of course, there will not be any update. And then in the next step, we need to modify the check events helper method so that moving right is set to true when the right arrow key is pressed and false when the key is released. So heading over to our alien invasion file, what we want to ensure is that if the event key here is equal to the right key, then we are setting self-ship moving right to true. And alternatively, if we have a key up event and we have the right key here, then again we are setting that to false. And finally, we also have to update our game loop. So inside of run game, we add self.ship.update, which refers to this update method here. And that of course is going to run continuously. And as long as we press down the right arrow key, we're going to move to the right. So let's take a look at that, and let's run our program again. And now when we press down the right arrow key, we are going over to the right side. And once we let go, we will stop moving. And that of course is a lot smoother than always having to press the key individually. Now we can do the same for the left side, of course. So again, we head over to the ship.py file. And in here we are going to add the self.movingLeft flag, which we set to false initially. And then inside of our update method, we add another if statement here. And here we are checking if moving left is true. If that's the case, then we are going to update the X coordinate again. But this time, of course, we're going to use a minus because we want to move to the left side. Now, in addition to that, of course, we also need to update alien invasion, specifically our check event helper method. And in here, we are also going to check, aside from checking if we have the right key pressed, the right arrow key pressed, if instead of that the left arrow key is pressed. And if that's the case, then we're going to set moving left to true. And then we are also going to cover the key up event. So here we're going to set moving left to false. And let's have a quick look at that. So if we now run our program again, we should be able to move to the right, but also to the left. And thereby we can basically navigate to the right or left inside of our game. Now at the moment the ship always moves 1 pixel per cycle when it goes through the while loop. But we can actually adjust the speed of the ship and customize it in the settings area. So to do that we can head over to settings.py and we can add an additional attribute ship speed, which we can set for instance to 1.5. And of course later on we can always control it from inside of our settings. So now it's going to move by 1.5 pixels rather than by 1 pixel. In order to use this new speed, we then need to head over to our ship.py file, and in here we are initially going to reference that setting. So here we're going to call self.settings and we're going to set that equal to aigame.settings, so basically referencing the settings we specified. We can then set the decimal value for the ship's horizontal position by specifying self.x, and we are turning that into a float because of course integer values are not specific enough, so we are going to work with floats, and we're using self.rect.x to infer the current x position of the ship. Then next we are going to, inside of our update method, update the ship's x value by actually setting self.x to increase by self.settings ship speed, so we're referencing the value inside of our settings. And we're making the same adjustments for moving to the left, again referencing ship speed inside of settings. Then next we can update the rec object from self.x. So here we're going to set self.rec.x to be equal to x. So the value that has been updated is then referred back to our rect value here. And once we set these values, we can head over and run our game again. And now our spaceship should actually run more quickly. And on macOS it may be necessary that we need to make some changes and run our game in the full screen mode, which is something we're going to implement a little bit later. Now at this point our ship will disappear off either edge of the screen if we hold down an arrow key for too long. So in order to avoid that we need to set certain ranges so that our ship cannot go off the screen. So in order to accomplish that, let's go back to our ship.py file, and inside of our update method we are going to add an additional condition. So here if we have that condition where we are moving to the right, we are going to add an additional condition that's checking that the right side of our ship is actually less than the right side of our screen. And we are going to add another condition to moving left, so that the left side of our rectangle is always greater than 0. And that ensures that we cannot go off screen. So if we check that out again, and we start our game, and we navigate either to the right or to the left side with our ship, then we shouldn't be able to go off the screen. So as I go to the very right of that screen, I should actually not be able to move off the screen. So here we stop and we cannot go any further to the right. And of course the same is true if we move to the left. Now let's also update and refactor part of our code that we wrote so far. If we think back, we had this helper method check events, which got quite long, and now's a good time to just refactor that and slim it down a little bit. So if we take a look at alien invasion again, and we take a look at check events, we can shorten this out quite a bit. So here, instead of having all these conditions, which basically check for moving to the right or the left, instead we are adding a new helper method, actually two separate helper methods, one to check for key down events and one to check for key up events. And we're passing the specific event as an argument to that particular method. And then of course we add those methods in here. So we check for key down events and we check for key up events, and everything we had in this particular branch here before, we just move that inside of that particular method. And of course our game will work just the same as before, but this is a good time to really refactor this code and make it a little bit, slim it down a little bit basically. So now that we're responding to key presses efficiently, we can add another way to quit the game. So far we always clicked on the X button of the window, but we can also quit our game by typing in a key. So in our case, we want to use the shortcut Q to end our game. So all we need to do is to head over to our Alien Invasion module, and inside of our check keydown events helper method, we can just add another branch to our if statement, and here we are going to check if the event is equal to the Q key being pressed. Then we are going to call sys.exit, which of course is the same call we used before to actually end our game, and this is going to end our game when we press the Q key. Now we can also run our game in full screen mode, so that when we launch it up, it automatically switches over to full screen mode. And for this also it's quite important to implement this Q key shortcut as well, because otherwise there will be no way to easily end our program, because we can't just click on the X icon anymore in the window. So let's implement that, and to do that all we need to do is to go up to our init method, and we basically modify our self.screen value here. So initially we are going to set the mode to full screen, and we're gonna let that start at the very top left side, the origin at 0, 0, and so our screen is set to the full screen here. Next we're going to set the screen width that we have to the width of the entire screen, and we are doing the same for the height. And now if we head back and we run our game again, it will actually start up in full screen mode. So now as we can see, we now have the full width and the full height of the window, and we can still navigate our ship. And of course, as we press Q, we quit execution and we go out of our game. So let's briefly recap what we did so far before we continue and we implement the shooting mechanism to shooting bullets with our spaceship. So initially we implemented our main file, Alien Invasion, and this contains the Alien Invasion class that we implemented, and this class creates a number of important attributes used throughout the game. So the settings are assigned to settings, the main display surface is assigned to screen over here, and the ship instance is created in this file as well, as we can see over here. And then we have the main loop of our game, our run game method, and the loop itself calls the helper method check events, update screen, and also ship update. Now the check events helper method here detects relevant events such as key presses and releases, and processes each of these types of events. So the methods check key down events, so our first helper method inside of this helper method, and then check key up events, which of course we write down here, which is another helper method we work with. And for now these methods manage the ship's movement, but the Alien Invasion class also contains update screen as an additional method here at the bottom. And this is drawing the screen on each pass through the main loop. So the Alien Invasion file is the only file we need to run when we want to play Alien Invasion. The other files like settings.py over here and also ship.py are being imported into this file. So our settings.py file contains the settings class, and this class only has an init method which initializes the different attribute values that we are using throughout our game. So here we can customize the game's appearance and also the ship's speed. And then of course we have ship.py. This file of course contains the ship class, and the ship class has an init method, an update message to manage the ship's position down here, and the blitme message to draw the ship to the screen. And the image of the ship is stored in the ship.bmp file, which is in the images folder that we created before. So that's the basic structure of our game. Now let's continue by adding the ability to shoot bullets. We're going to write some code that fires a bullet, which is represented by a small rectangle when the player presses the spacebar. Bullets will then travel straight up the screen until they disappear off the top of the screen. So let's start by adding some bullet settings. So if we switch over to our settings.py file, at the end we can add some bullet settings. So we're going to add the bullet speed, which we can then of course configure and adjust, but also the bullet width, the bullet height, and the color of the bullet. So these settings are going to create a gray bullet with a width of 3 pixels and a height of 15 pixels. And the bullet is then going to travel slightly slower than the ship, so we have a speed of 1.5 compared to 1.5 for our ship. Next, let's create a separate bullet class, and for that we're going to create a separate module. So bullet.py is a new file that we create inside of our projects folder, and specifically inside of Alien Invasion. And inside of this we are going to initially import Pygame, of course, and on top of that we are going to import the sprite class here. We're then going to create a separate class, bullet, which is going to inherit from sprite. And this class is used to manage bullets fired from our ship. Of course, we again have an init class, and similar to how we saw it done in the ship class here, we again have an additional parameter AI game. So as we initiate our bullet class, as we instantiate a new object, we are going to pass the current game to it. Since we are building on top of what the sprite class already provides, we are initially going to call super to reference the sprite class here and basically inherit the behavior defined in the super class. And then we are going to initialize our screen, settings, and the color. The color here is defined inside of the settings module, and the other two are referenced directly from our game. So of course that's defined inside of Alien Invasion. We are then going to create a bullet with a rect at 0, 0, and then set the correct position. So here we are again referencing the bullet width and also the bullet height, which of course we defined in our settings module. And then we want to make sure that the bullet actually is created at the very same position where our ship is, because of course we are shooting it from our ship. So therefore we are saying that we are creating it in the mid-top section, which is set to the mid-top area of the rectangle defined in our ship class. So that basically has the effect that it looks like we are shooting it straight from the ship up the Y position. And of course that's what we are defining here. So we are storing the bullet's position as a decimal value here in self.y. We then define two additional methods. One is the update method here, which is used to move the bullet up the screen. And the other one is draw bullet to actually draw the bullet to the screen. So regarding update, we first of all define the Y coordinate here, which is defined by, of course, the bullet speed that we defined in our settings module. And since we are basically moving up the screen, we have a negative coordinate that we are updating. So as we basically decrease the Y coordinate, we move up the screen. And that's of course because on the top left side we have the 0, 0 coordinate. And that means as we start at the bottom and go up, we basically decrease the Y value. And then of course we need to update the rect position itself, referencing the updated Y position here. And finally, we are using pygame.draw to draw a rectangle here, passing to it the screen, the color, and the rect itself. And we have to take this approach as opposed to what we did previously, because for the bullets we don't actually have an image that we're using, but instead we are specifying a rectangle that should be created. So now that we have a bullet class and the necessary settings defined, we can write code to fire a bullet each time the player presses a spacebar. And we'll create a group in Alien Invasion to store all the live bullets, so we can manage the bullets that have already been fired. This group will be an instance of the Pygame sprite group class, which behaves like a list with some extra functionality that's helpful when building games. So let's take a look at that. Let's switch over to our Alien Invasion module here. And starting out, we can head over to our init method here. And here, just below self.ship, where we instantiate a new ship object, we are going to instantiate our bullets here, referencing Pygame sprite group. And then of course we need to update the position of the bullets on each path through our while loop. So taking a look at that, we have our run game method here, and here we are going to call update on self.bullets. So basically we're referencing the update method that we specified here, where again we specified that we always want to update our y coordinate so that we move up the screen, and then of course we update that in the rectangle itself. So by referencing that here in our run game method, this will be called automatically in the main loop for our game. Next we need to modify our helper method check keydown events. So this method here, and here we want to make sure that we fire a bullet when the player presses the spacebar. So we don't need to actually change our check key up events method here, because nothing is going to happen when the spacebar is released. But we also need to modify update screen to make sure each bullet is drawn to the screen before we call flip. So let's start out, and actually on top we are going to import our bullet class from our bullet module, which we created before, and then going over to our check keydown events, we are going to add another branch to our if statement. Here at the very bottom we are going to add elif, and we are checking if the key that is being pressed, so the event that's registered, is actually equal to the spacebar. And if that's the case, we are going to call a helper method called fire bullet, which we of course need to define. So here we have that helper method, and that's going to create a new bullet and add it to the bullets group. So here we simply instantiate a new bullet object, and then we are going to call add on self.bullets and pass the new bullet that we just created to it. And then finally, scrolling down here, we say that for each bullet in our bullets group, we are going to call draw bullet on it to basically create our bullet. So that again is this method we defined here. So here we are referencing draw.rect to create a new rectangle that we draw to the screen. And just to note, the add method that we are using here is kind of similar to the append method we saw before, but it's a method that's written specifically for Pygame groups. And then the bullets.sprites method here returns a list of all sprites in the group bullets. And then to draw all fired bullets to the screen, we loop through the sprites and bullets and call draw bullet on each one of them. So let's check that out. Let's actually run our program, and if everything works correctly, we should actually be able to fire some bullets. So here we're just calling our program. Again, we have our little spaceship, and now if we press the pace bar, we can see we are firing those bullets here, which are then drawn to the screen and slowly go up the screen. And of course we could later on adjust the settings and then, for example, increase the speed of the bullets and possibly also of the spaceship here. So that works properly, but we already saw that we can shoot quite a lot of bullets, so we may want to restrict that. At the moment, the bullets that we fire disappear when they reach the top of our screen, but only because Pygame can't draw them above the top of the screen. And the bullets actually continue to exist. And that can be a problem because we need to basically calculate where the bullets are, and that's going to use up a lot of memory. So therefore, in order to resolve that, we can actually get rid of the bullets once they basically leave the screen, they're off the screen, so we don't need to do any unnecessary calculations and use a lot of memory. So in order to do that, we need to detect when the bottom value of a bullet's rect has a value of 0, which indicates that the bullet has passed off to the top of the screen. So over in our alien invasion file, we can actually add a bit of code to check if a bullet is outside of the screen and then remove it from existence. So here inside of our run game method, we can add an additional section here, and we're going to check for all the bullets. Inside, we are going to check if they are at a position less than or equal to 0, and if that's the case, then we're going to remove them. And just to verify that it's working correctly, we're going to print out the length of the bullets, so how many bullets currently exist. So once they're off the screen, there should actually be no bullets around, so we should get back a value of 0. And because we can't remove items from a list or group within a for loop, we have to loop over a copy of the group, which is what we're doing over here. So we use a copy method to set up the for loop, which enables us to modify bullets inside the loop. And then we check each bullet to see whether it has disappeared off the top of the screen. And if that's the case, we are going to remove it. So let's actually verify that, and let's run our program one more time. And inside of that, we are just going to fire, let's say, 3 bullets here. And then once they basically are off the screen, we can basically verify that the length is 0, so that they actually have been removed. Alright, so our bullets are off the screen. Let's terminate our program, and we can see indeed we print out a value of 0 at the end. That means all the bullets have been removed and they no longer exist. So next, let's limit the number of bullets. At the moment we can shoot a lot of bullets, but that makes the game quite easy, so we want to make sure that the player can only shoot a certain number of bullets. So in order to do that, let's head over to our settings one more time. And in the bullet settings here at the bottom, we are going to specify the number of allowed bullets at a time. That means in this case we set it to 3. That means there can only be 3 bullets. And once they reach the top of the screen, they are being removed. And then of course we can fire a new bullet. So once we specify that, we can head over to Alien Invasion. And here inside of our method fire bullets, we then add an if statement, and here we check that if the number of bullets here is less than the bullets allowed, then we can actually create a new bullet. If that's not the case, we are not able to fire another bullet, so there can only ever be, in this case, 3 total bullets in existence. So we want to keep our Alien Invasion class well organized. So now that we have written and checked the bullets management code, we can move it to a separate method. So to do that, we can create a new method called update bullets here at the bottom. And then we can move the code that we originally added up here on top in our run game method. We can actually add that to the method. So let's move this down here. So all of this code here, we're going to cut that out and move it down here inside of update bullets. And then of course up here in our game loop, we can then reference this. So here we're going to say we are going to call our helper method update bullets. And it should still work as before, but now our run game method is a lot cleaner because we moved our code down here. So let's verify that it's still working properly by running our program. And again, we can navigate here and shoot the bullets, but only a total of 3 bullets, so that's still working properly. We learned how to plan a game and how to use Pygame to create a game using Python. We also learned how to set up a background, how to add a game object, how to navigate, and how to shoot bullets. In the next video, we're going to focus on adding enemies to our game. See you guys in the next video.